Hello and welcome to SudoKanard. We're here to solve this exam Sudoku by Turkish author Salih Alan. It was featured in the recent WPF Sudoku Grand Prix, the round 6 of 2024. And I remember this puzzle from, I found it to be very impressive in the way it's conceived, because exams is one of my favorite variants of Sudoku. It's a variant for which I've created quite a number of puzzles, and I usually use much, much more clues than this one. So the special rule of exams is that whenever you have a number in the margin, it is the sum of the first few digits, and how many digits is just the first digit. For example, this one means that we have the sum of the one first digit, which is a 1. So we sum one digit, and that's the sum is 1. So it was worth 72 points, which means it's supposed to be a somewhat difficult puzzle, and it was indeed not that easy. So let's start. So this one is obvious. We must know that 45 is the sum of all digits from 1 to 9, so that here we must have a 9. 45 is the sum of all 9 digits starting from this direction. Then we have this 6. 6 could be the sum of 3 digits, but then the other 2 digits would have to be 1 and 2, which is not possible because of this. So only 2 digits will work here, and this has to be a 4. 41 could be the sum of 8 digits with just a 4 at the end, or it could be the sum of 7 digits with 1 and 3 at the end. So this will have to be disambiguated later. 10 could be the sum of 4 digits, but this would need the next 3 digits to be 1, 2, 3, which is not possible because of this one. So that's not an option. We could have 2 digits with 8 being in second place, or we could have 3 digits with 2 and 5 in those positions. So 2 options at this point. 36 requires at least 6 digits. We could have 6 digits with 3 digits here summing to 9. For example, 1, 3, 5. Or it could be 8 digits with the 9 here, except that 9 wouldn't work with this 10 clue because we said that, well, with the 2, that this is 8. Oh, and that's kind of interesting. And with a 3, those will have to be 2 and 5. So the only options for this digit are those. So 8 will never work, but 7 could work, provided that those 2 digits sum to 9, which means that 5 would work with 1 and 3 if this is a 6. So this is still an option. All right. Let's have a look at 20. 20 could be a 3 with 8 and 9 here, which means that this would have to be a 7. 4 would be a possibility if 4 was not already in this cell. 5 is also an option. So we have a sum of 20 here. Those must sum to 25. This is totally possible. And then we have those clues, the 25 on both sides. And that is a very interesting clue, because we know, noting that the sum of those two clues exceeds 45, it means that the set of digits that sum to those numbers must overlap, and the overlap must sum to 5. So that's the first thing. The second thing is that 25 requires at least 4 digits, and it can't be more than 6 digits. So the options are from 4, 5, and 6. And then the sum of those two digits must be at least 10 because there has to be an overlap. So we can't have 4 and 5. So it's either 4 and 6 with an overlap that is only digit 5, because 50 minus 45, or it could be 5 and 6, meaning that the overlap is made of two digits. So if this is 5 and 6, it means that 2 will be in the overlap. The overlap will be here or there. And the digits must sum to 5, so 2 must be with a 3. And that doesn't work. So this is not 5, 6, this is not 4, 5. It has to be 4 and 6. So we don't know which one is the 4, which one is the 6, but we know that the overlap must be digit 5 in one of those two cells. So this is some rather advanced logic, which is quite common for advanced X-sums puzzles, but I can understand that this puzzle is not for everyone. On this side, we have basically the same logic. Those must be from 4, 5, 6, and the sum of the clues is 50, so the overlap must be made of digits summing to 5. And the interesting part is that 4 and 5 doesn't work. So 4 and 6 would mean that the overlap is a single digit 5, which would work with 5 in this position, not in this one. 5 and 6 would mean that the overlap is made of two digits, either here or there, summing to 5. So the overlap would need to contain the 4. That's not possible. So the only possibility is 4 and 6. And the overlap is made of the single digit 5. So 5 is here, which means that this is 4, this is 6, this is 4, this is 6. So the overlap is just here. We have the 4 digits here, the 4 digits here, the 6 digits there, the 6 digits there. And I must say I was really, really impressed. I found this logic somewhat naturally because I've created X-sums puzzles, and this is not unusual logic, but it's really beautiful. Now this is 9. We must go to 25, so we need 16. Those are 7 and 9, and those are 1, 3, and 8. So this is 8, and this is a 1, 3 pair. 4 plus 5 is 9, so those must sum to 15 without using the 6, so they must be 7 and 8. We still need 1, 3, and 9, so this is 9, and this is a 1, 3 pair. Here we need 6 and 7. And I remember thinking at this point, this will never be unique. There's so little information at this point. How can we finish the solve with just that? And I'm still in awe that this should be the case. And I remember thinking about this and that. I mentioned earlier that if this is 6, then those 3 digits must sum to 9. Now there are only 3 ways of having 3 digits sum to 9. One of them is 1, 2, 6. Another one is 1, 3, 5, and the last one is 2, 3, 4. And we must appreciate the fact that none of those 3 options is valid, because 1, 2, 6 would contradict the presence of 6 here. 1, 3, 5 would be incompatible with the choices here. 2, 3, 4 would be incompatible with the choices here. So that all 3 options here have to be ruled out, and this is not a 6, this is 7. It means that those 2 digits must sum to 9, 2 would be with a 7, that's not possible. 5 would be with a 4, which is not available. So this can only be 8, and it means that this is finally a 2, and this has to be a 1 to satisfy this 36 clue. This is now 3, this is 1, this is 3, this is 1. And now that we see 1 and 3, we know that this will never be 1 or 3. And if this had to be a 7, those two cells would sum to 4, which means that they would have to be 1 and 3, but this is not possible. So that this is finally 8, so this is 7, this is 8, and this has to be 4 for the other 8 digits to sum to 41. And now that this is 8, we can't have 8 and 9 in here, so that this 3 is impossible, that has to be a 5. And at this point, we know that the sum of those 5 digits will have to be 20, and the rest will have to be just plain Sudoku with that much empty space. So let's move on to solving this. Those ones here, place a 1 in there. So this will have to be addressed at some point. And I'm thinking that if this is 9, then those 2 digits sum to 14. The other 3 digits will have to sum to 6, which means that they would have to be 1, 2, and 3. 3. So that's 2, that's 3, that's 1. That's a possibility. If this is 7, then those 2 digits sum to 12. And the other 3 digits then must sum to 8 without using the 5, so they must be 1, 3, and 4. So we have either 1, 3, 4 or 1, 3, and 2. So in all cases, this has to be the 1. The 3 must go there, and this must be 2 or 4, but 4 is not available, so this has to be a 2. And finally, this is 9, and this is 7. And now I think that all X-sum clues have been fulfilled, and the rest is really just plain Sudoku. So let's do this. 7 is nowhere here. This 7 is not there, so that is 7. We have 7 somewhere here. Well, actually, those 3 digits must be 6, 7, 8, and this is not 7. Now, those 4s place a 4 here. This 9 goes there. Those have to be 2 and 6, but there's a 2 here. Here we need 3, 5, and 9. 9 can only be here because of this 3. This is 5, this is 3. 1 can only be here. This has to be from 6 and 8. This row needs a 3. 3 is not there. It's not there, so it's here. We still need 5, 7, and 8. So this is from 5, 7. This is from 7, 8. And I'm seeing a 6, 7, 8 triple in here. I still need 4 and 9 in those cells. This column still needs 1, 3, and 8. This 8 goes there. Those are 1 and 3, but there's a 3 here. 3 goes there. 2, 5, and 6. There doesn't seem to be anything to disambiguate. Here we need 2, 5, 6, and 9. So this is from 5, 6, 2, 5, 6. 9 is somewhere here. I think we'll come back to this later. Where is the next place to look? So oh, sorry about that, 6 and 8, this has to be a 7. Here we need a 3. It can only be there. Those are from 5, 6, and 8. This column still needs 4, 5, and 9. This is from 5, 9, 4, 5, 9, 4, 5, 9. So there's still some work to do with classic Sudoku. 2, 5, 7, 8. 7, 8 here, so this is from 2 and 5. And that's interesting because here we get a 2, 5, 6 triple. And I'm seeing that on this row, 9 doesn't go here, so 9 goes there. And this is the only place for 4, so that's not 4. 4 goes there on this column. And on this row, 6 is here, so that's not 6. 5, 6, 7, 9. So this is from 5, 6, 7. Oh, this is not a 1. That's a 2. I just hope it won't break after this mishap. All right, this column still needs a 1. It has to be here. The rest is 5, 6, 7, 8. There's 8 here, so this is, and there's 6 here, so this is from 5, 7. And so 8 is here in the column, so that's not 8. 8 in the column can only be here. So the rest of the column still needs 5, 6, 7, 9. So this is from 5, 7, 9, and I'm seeing that in this box 7 is in here. So that's a 6, that's 7, that's 8, that's 6, so that's 5, that's 8, that's 6. This is not 6. 6 is here. This is 9, this is 5, 7, 9, 5, 7, and this is all unraveling just by magic. This is 5, this is 2, this is 7, that's a 2. This can now only be a 6, that's 9. This has to be a 2, 5, 6, and 5. This is really, really a splendid puzzle. I said it at the beginning, I was very impressed when I solved it during the contest. And for this second solve on video, I am impressed again. This is a really, really a beautiful X-sum Sudoku. And actually the whole round was really one of the best rounds of Sudoku Grand Prix I've ever seen, I think. Thanks for watching this video. See you soon on SudoKanard.